So another step is completed. We have deployed our backend through Lambda as well as EKS. Now the next and very crucial step that comes into picture is observability. And of course, once everything works properly, we will move to CI/CD to automate deployments. In this video, I'm going to show you how I added production grade observability to our AI knowledge assistant, a RAG-based chatbot running on AWS EKS. By the end of this video, you will have a live Grafana dashboard tracking real-time request traffic and error rates, end-to-end latency broken down into vector search and LLM generation, token usage and LLM cost monitoring, pod CPU and memory from the cluster itself. So this is a full walkthrough, code and Kubernetes config along with Helm and Grafana dashboards. Let's get into it. We have our RAG agent or the fast API app running in the default namespace. It exposes a metrics endpoint in Prometheus format. Now we have another namespace called the monitoring namespace. So we install kube Prometheus stack via Helm. So what it does, it gives us Prometheus, which scrapes metrics every 15 seconds, Grafana for dashboards, Alert Manager for alerts, Node Exporter for EC2 node metrics, and Kube State metrics for pod and deployment state. The key glue between namespaces is a service monitor, a Kubernetes custom resource that tells Prometheus which service to scrape and how. The data flow is from fast API through metrics to service monitor, then to Prometheus, and then finally to Grafana. Now, to write the metrics, I have created a new file called the metrics.py, which is lying inside app and then core folder. So we have 5 metrics, 2 counters and 3 histograms. Notice the label dimensions. Status on requests lets us split success versus error. And type on tokens lets us separately track prompt and completion costs. So one important note here, labeled counters do not appear in metrics until they are first used. This trips a lot of people up when debugging Prometheus. Next, two things need to happen. Exposing the endpoint and recording the metrics on every request. So in main.py file, we add a Prometheus fast API instrumentator. So this one line instruments all HTTP endpoints automatically. Request count, latency, status scores, etc. So this also gives us the metrics endpoint for free. So we do not have to additionally create an endpoint slash metrics. Now in app API routes and chat.py, I wrap each stage of the RAG pipeline with timers. So as you can see for vector search, this is the one. So this is the timer. Similarly for LLM generation and so on. Now we have this LLM service.py file inside the services folder. So here we are recording the token usage right where the OpenAI response comes back. So this is important because the LLM is where the token counts are available. So that's where we record them. Now the Kubernetes sites. So two files needed updating. One is the service.yaml. So here the service needs a label on the metadata, not just in the spec selector. And then we need another file called the service monitor. The service monitor matches by service labels. So if you miss the metadata label, Prometheus targets show up, but no custom metrics ever appear. So this is basically the new file that wires Prometheus to our service. And if you see the name here, release. So this release monitoring label, this must match the Helm release name. That's how the Prometheus operator discovers service monitors. Now let's install the monitoring stack. So I've added some Helm commands here in the make file. So deployment is one command now. So this entire command Helm install, what it does, so this creates the monitoring namespace, adds the Prometheus community Helm repo, and then installs the kube Prometheus stack with Grafana, Prometheus, Alert Manager, Node Exporter, and kube state metrics. So once these are configured, these are installed, we need to verify that everything is running. For that, we have this single command monitoring status, which is doing nothing but kubectl get pods to check the status of the pods, the status of the service, and the status of the service monitor, whether it is applied or not. So to finally apply the service monitor, this is the command. It is the simple kubectl apply command that you can see. Now building the Grafana dashboard. So before I deep dive into the Grafana dashboard, let me show you two more commands, Grafana forward and Prometheus forward. So basically what we do using these two commands, we are actually port forwarding the port for Grafana so that we can access it from our local machine. And similarly, we are doing the same for Prometheus. So what happens once we execute these commands, our Prometheus runs at port 9090, whereas our Grafana runs at the port 3000. So as you can see, this is how the Grafana portal looks like. And this is the Prometheus. So we have this query tab, alerts, status, and these are the queries that you can execute to check counts or the values. Now moving back to the Grafana dashboard. So before I deep dive, let me tell you one more thing. So Grafana tries to pull the data from the Prometheus. So the data source for Grafana here is Prometheus. So we expose each and every metrics to Prometheus, and from Prometheus the data automatically goes to Grafana in the interval of every 30 seconds. So, so this is the dashboard that I have built. So how did I create this dashboard? So the first and foremost important step is basically the data source setup, and this is critical. So you go to data sources, and from here you can add a new data source, and you can select Prometheus. Once you select Prometheus, this is the place where you need to give the entire URL of the Prometheus. So the URL must be the in-cluster DNS name, not the local host. So it would be basically in the format like this. And once done, you can just click save and test. So since I have already added, I'm not repeating this again. So once it is configured, you can come back to data sources, and from here you can click this button, build a dashboard, and then you select import dashboard, and here you need to upload a JSON file. So I already have a JSON file, Grafana dashboard.json, which I had generated using ChatGPT. So this is basically a description of what all components I want to see in my dashboard. So it's a JSON format data where I am basically uh, identifying or denoting the panels that I want to see. So I have one panel to see the rate request, RAG request total, and basically the request seconds. Then I have another panel for seeing the errors. And then I have few other panels, for example, for the end-to-end latency. So everything is getting added in the form of array of objects. And then we have another panel to see the time series or the histogram charts, to check the pod, CPU, and memory. So once you have this file, so or you can just directly use the same file from my code base, and you need to just import this JSON file here. Once this is done, come back to dashboards, and you will be able to see that your dashboard is appearing here, AI Knowledge Assistant. So you need to go inside, and this is how it will look like. So this is how I had described the panels. So request per second, error rate, latency, end-to-end latency. This is nothing but P50, P95, P99. And we have vector search latency for the Pinecone vector search and OpenAI generation. So this lets you instantly see whether slowness is actually in the retrieval or in the generation of tokens. And then we have LLM cost and tokens. Basically, it gives you the tokens usage for both prompt and completion tokens. So we have the prompt and completion token rates per hour as a time series, plus a stat panel, to cumulative total since the pod started. And then we have matrices for pod resources, pod memory for the basically the CPU and memory directly that is coming from the Cube Prometheus stack metrics. So this entire dashboard auto refreshes every 30 seconds. So what will happen, like if you do a chat query in the front end or using curl, so you will be able to see this, visualize this metrics over here. So till now we had 344 prompt tokens used and 33 completions.